Welcome to another lecture on Java. We are still exploring the JVM and we are now going to look at the execution engine of the JVM. And these are the contents of what we look at under the execution engine. So this is a diagrammatical representation of how the execution engine looks like. So the interpreter. Java, we know that it's platform independent programming language, and this is achieved through the Java interpreter. We know that we can run Java on many platforms that have Java interpreter. So what the Java interpreter does is that it takes that bytecode, or you can say those class files, and converts them into code that is understood by the underlying architecture, underlying operating system. Because you can run code on Linux, on Windows, or on Mac OS. So it will take those bytecode instructions, interpret them to find out what native operation must be performed, and execute those native instructions. And this is through the native method interface, which is actually used to interface the native method libraries in the JVM. And if you look at on your Windows environment, you will see that we have DLL files inside the Java home directories, one of the directories. Then if you are on Linux or Unix, you will see those files. They are .so files, and these are platform specific. Then we have the JIT Compiler. This is an optimization in the execution engine to improve performance, so that we can have an application that is fast. So you find that there are situations where instructions set repeats, and so if they repeat, it is pointless to always do reinterpretation for them. So the JIT compiler will seek or will try to generate those instructions and keep them ready for execution all the time, so that it doesn't always need to do reinterpretation. And this actually improves performance. And the JIT compiler uses what we call the Hotspot profiler to know which piece of code is frequently interpreted and executed, so that it achieves its goal. We also have what we call a garbage collector. This is responsible for cleaning up unreferenced objects in memory. Garbage collection is carried out by a daemon thread called garbage collector. So how can an object be unreferenced? If an object runs out of scope, let's say you're in a method and then you create an object there, and that method gets fully executed, it means the scope of that object that was created in there has run out. Then that object needs to be garbage collected. Or in the case where you have anonymous objects, an object that does not really have a reference to it. It was created on the fly, and when it goes out of scope as well, and it's not referenced, or it doesn't use any reference for other object, it will garbage collected. Or when a reference is nullified, let's say you have string str equals to something, and then below that you say str equals to null. It means whatever str was pointing to has been nullified. That object that it was pointing to is out of scope, is no longer referenced, therefore it's eligible for garbage collection. Or maybe when you do reassignment of a reference to some other object, the object that it was previously pointing to can be in a position where we can say it's available for garbage collection, provided it does not have other references that are pointing to objects that are in use in memory. Reassignment. Then garbage collector. We cannot force garbage collection as a developer, but we can suggest to the JVM to start garbage collection by invoking the system.gc method. When heap space is all used, we can run out of what we call out of memory error, except that will be thrown. Then the garbage collector has actually several spaces. We have what we call the young generation, the old generation, the permanent generation. And the permanent generation is the one that we said it's now called the meta space, where we are storing the metadata. Then we have the young generation and the old generation. The young generation is divided into subsection: hidden space, survivor space. So the generation here is actually used to denote the lifespan of an object. It can be young, old, or permanent. And it also denotes, for young generation and old generation, it denotes how many cycles of garbage collection an object has survived. So the young generation, it's a place where new objects are created and stored. And new objects go into this. You can think of it as a Genesis, like in the Bible. Then we also have the survivor space. So supposing that garbage collection takes place, and some of the objects in the hidden space survives garbage collection, those objects will be moved into what we call the survivor space from the hidden space, because they have survived garbage collection. And if they continue surviving garbage collections from their different steps, they will end up being moved into old generation. So old generation, objects that have survived many cycles of garbage collection go into old generation. This is where caches eventually go in. Then you can actually control the threshold of promoting from young generation to old generation. We have -XX, which is max tuning threshold, the number to decide when to promote from young generation to old generation. We can say, okay, if this object has survived maybe 20 garbage collection cycles, we are moving it into old generation. For more on garbage collection, you can watch this YouTube video. They explain this lecture very nicely.